Good morning, Lisbon. Today I'm presenting QuestWallet, which is a wallet extension implementing ERC 4337. So what's in the account abstraction? Gasless transaction is a possibility, social recovery is another one, and other extended functionalities. But today we're focusing on gasless transaction. And how do we make gasless transaction possible? Well, in our wallet we have two stakeholders, our Quest sponsors who will sponsor the transaction of our users in exchange for our users doing a quest that will teach them about our sponsors. So a quest can be watching a video, reading a blog post and answering a poll, or posting a tweet. Our users, on the other hand, they will try to post a transaction, be prompted with a quest, complete the quest, and their transaction is gasless, paid by your sponsor. So it's a win-win situation, guys. For our sponsors, it's a new advertisement channel. For our users, it's basically a learn-to-earn tool. So, how is this possible? Well, it all starts with our sponsors. Our sponsor sends us quests and funds to a paymaster to pay for the gas fees of our users. Our users, they're gonna give us a user operation they want to execute. We'll send them a quest based on that. They'll complete the quest and we'll give them a quest proof to prove that they actually completed the quest. They'll be able to sign the user operation and the quest proof, send it to an open relay. A bundler will see that juicy transaction on the relay, send it on chain. This transaction will go through the smart contract account of our user and through the paymaster that deployed by our sponsor. This paymaster will send a kickback to our executor, giving them the refund of the gas fees they spent to execute the transaction of our user and a little fee to incentivize them to take that juicy transaction. And the transaction will end up on chain and our user will have had a gasless transaction. Today, our implementation of this architecture is based on the Safecore SDK and on the Gelato relay. So we send the user operation through the Safecore SDK to the Gelato relay. The Gelato relay is actually a relay and an executor at the same time. So we send funds to the executor of the Gelato one balance relay. And so as soon as we send our user operation with our key to the Gelato one balance relay, the Gelato one balance relay knows that our user actually executed the quest and posts the transaction on chain using the funds that our quest sponsor put on the Gelato relay. And now it's demo time.
So, as a user, I don't want to pay for gas, but I want to send some ETH to my friends. And as I am triggered to send my transaction, I have a little quest to fill up. And QuestWallet asks me today about ZK rollups. I think it's a very promising scaling solution in Ethereum. Main limitation of a ZK rollup: devs need to write the smart contract logic in risk. I think this is true. They cannot interact with each other within the layer 2 environment. This is true. Do devs need to write smart contract logic in Viper? Probably not true. So all of the above are correct. No, the third answer is wrong. And then finally, I get to know about my sponsor. Scroll collaborates closely with the EF to find the best way to implement the EVM circuit. Let's say I put false. If I put false, I can learn that Scroll ZK EVM can provide the same experience for developers and users. It is orders of magnitude cheaper without sacrificing security. So actually, Scroll does collaborate with the EF. And this is time for me to send my transaction. And finally, it can be processed because my quest was answered correctly. And I can check that on Etherscan. So here it is, 0.005 ETH successfully transferred to the D88 wallet. And that's it.